So let's say that I have a car that's driving down the road. And it's traveling this way with some velocity. It's speeding up because it's got forces acting on it. And the forces acting on it are gravity down, normal up, friction to the left. There is air resistance too, so if you wanted to add in drag, you could add in drag too. And then an applied force forward. Okay, so there's my forces. Net force, we've talked about in the notes, is the total force acting on an object, and we find it by adding the forces together. So on first glance, you're probably thinking, oh, okay, well, I add normal plus gravity plus applied plus friction plus drag. I add them all together. Well, not exactly. And the reason why is you only want to add forces that are in the same direction, as what the change is. Okay? So how do you know what forces to add for F net? You add any forces in the same or opposite direction of the acceleration. So anything in the same direction or the opposite direction of the acceleration is what you're going to add together. Okay? So if I look at this example here, I'm looking at this and I'm saying, okay, what are my forces in the direction of the acceleration? Well, I've got an applied force. My acceleration is right, so I've got an applied force. I've got drag in the opposite direction, so you would be adding a negative, but you can think of it as subtracting 2. And I've got friction in the opposite direction. I've got normal up, which is not side to side. I've got gravity down, which is not side to side. Therefore, the only forces I'm worried about for the net force are these 3. Applied, drag, friction, that's it. So how do I know what forces to use? I find the forces that are in or opposite the direction of the change. In this case, horizontal. So applied, drag, friction. Okay? That's important because you've got to be careful about just randomly adding things. It's easy to do, easy to forget about, and that sort of thing. Okay, what are the steps for solving force problems? So step 1, draw a diagram. You absolutely have to draw diagrams because I need to see the following 3 things. I need to see forces. I need to see the motion. I need to see acceleration. Hey, remember this picture I drew up here? That's exactly what I want. Object, forces, motion, acceleration. I want those 3 things. Forces, motion, acceleration. That's what I want. Now, you are more than welcome to color coordinate. If you're saying to yourself, Mr. B, this looks like a great way to use a lot of pretty colors, you are more than welcome to. I would suggest doing it. It's what I do. And it's easy to help discern the differences. You don't have to. If you want to do everything in pencil, totally fine. Okay. But that is an option if you want. And I got all the markers and everything in the back. Okay. C, knowns and unknowns, nothing new there. Okay, D, solve for the net force. And E, finish the problem, whatever it asks you to do. It is possible to do D and E together. It is possible to set up the equation so that you're fine. So, like, basically, you set what you have to what you need, and you skip the net force section, and you're totally welcome to do that. If you're used to doing it that way, which some of you may be, you're welcome to do that. So, let's look at an example. Let's look at two different types of problems I could ask you to do. And then I'll give you some time to try on your own. So, same as pushing a couch, which has a mass of 40 kilograms across the floor with a force of 100 newtons. If the kinetic friction on the couch is 30 newtons, A, what's the acceleration of the couch? And B, what is the applied force if the acceleration is 2 meters per second? Okay, let's start with A. So the first thing I need to do is draw a diagram. So I'm drawing a couch, a very convincing one if I do say so myself. Draw Sam. Okay. Then I need the three things. I need the forces, the motion, the acceleration. So the forces are normal up, gravity down, applied to the right, and friction to the left. We don't really need to worry about drag on a couch moving across the ground. Technically it's there, but it's so insignificant it's not worth worrying about. Okay, then we need the motion. So the velocity, it's traveling this way. And then we need the acceleration. Well, Sam is pushing at 100 and friction is 30. So there's not as much friction as there is forward force. So it's going to change forward. So there's A checked off, B checked off. I drew the diagram, I labeled the forces, the motion, the acceleration. So now I need to find the knowns unknowns. That's also pretty straightforward for this here. It told me the mass is 40. It told me the applied force is 100. It told me the friction force is 30. And it asked me to find the acceleration, A. Okay, then I need to find the net force. There are two ways to find the net force. You can either do F net equals ma, or you can add the forces together. Doesn't matter, you just pick. Now, generally, one of them will work and one of them will not. In this case, we don't know the acceleration, so we can't multiply it by the mass if we don't know what it is. So this is not going to work. However, this will, because we know all the forces acting in the direction of the change in motion, so the acceleration. I know the applied force, it gave it to me, it's 100. I know the friction force, it gave it to me, it's 30. So to find the net force, I'm just going to add those together. F net equals 100 plus, well, friction's in the opposite direction, so it would be a negative 30. Again, if you subtracted, that's fine. Gives me 70 newtons for the net force. But I'm not looking for the net force, I'm looking for the actual value for the force. Okay? For the acceleration. So, now that I know the net force is 70, I know the mass and I can solve for the acceleration. So, F net equals ma, so in this case, 70 equals 40 times A, divide both sides by 40, and you get acceleration equals 1.75. At least I believe that is what that is. The mental math in my head says it is. So. There you go. So that's the first type of problem you could see. given information about the forces, solve for acceleration. That'd be the first thing. The second type of problem you could say is given the acceleration, find the force. So I'm not going to redraw the picture. It's the same problem. But I am going to write down what A is now. The mass is still 40. The friction force is still 30 in the opposite direction. However, I don't know what the applied force is anymore. It says find what the new applied force would need to be. So, just like before, I'm going to find the net force first. Well, I don't know all the forces acting, so I can't do this one. But I do know the mass and the acceleration. Mass is 40, acceleration is 2, gives me 80 newtons. And now that I know what the net force is, I can plug that in and find the missing force. So 80 equals 100, FA plus negative 30. Add the 30 to both sides, and you get the applied force equals 110. And there you do go. Any questions on that one? What I did, how I did it, what to do? All right. Flip her over to the back.